Okay, so another situation. Reinforced concrete pa rin. Mahilig yung examiner natin sa uh, pile footing, pile cap. This is a pile cap. And pwede rin mga footing. Basta mahilig siya sa mga problem na ganito. So, we have here a 600 mm square column is centrally located on the pile cap. Yan. So, we have 9 supported, the pile cap is supported by 9 of 350 mm square precast concrete piles. Square concrete piles. Dimensions given A, B, then C, and D. Effective depth of the pile cap is 400 millimeters. Ultimate axial load 3060 kilonewtons. Then ultimate moment about the y-axis. FC prime, Fy given, and the strength reduction factors. Alright, determine the maximum beam shear stress in the pile cap. Punching shear stress and the required spacing of 20 mm diameter bars for the critical movement. So, unang-una, kailangan talaga natin makuha yung critical reactions on the pile. Since meron na tayong moment dito, the reactions on the pile are not equal. Okay? Meron siyang mas pabor sa moment. Mas lalaki yung isang side ng ating reaction on the pile because of the moment. So, lagyan ko lang ng mga values, dimensions. Alright, so kung titingnan natin yan sa 3D, the moment is applied about the y-axis. Importante yan. About the y-axis. No, kasi pag mabaligtad mo yan, I'm sure merong lalabas dyan. Ganun ka strict to si examiner. So, ito yan. About the y-axis. Tawagin natin siyang MU. Okay? So, meron tayong PU. That's the load. 3060 kilonewtons. So, about the y-axis, pinakita lang natin to para mas maintindihan yung loadings. Alright. So, yung reactions dito, since meron tayong moment, pinupush ng moment yung ating pile on that side. No, ito yung pinakamalaking reaction. Ito naman, hinihila. Means liliit yung reactions dito. At the center, at the neutral axis, ano lang yan? That's just force over the number of piles. Ano yan? Na basta sa neutral axis. Hindi ito maaapektuhan ni movement. So basically, magiging linear yan. Tawag ko siyang line 1, line 2, and line 3. So I can call this one as RU1, RU2, and RU3. Each of these are RU1, each of these are RU2, and each of these are RU3. Okay, to solve for the reaction, yung general formula natin basta combined axial and bending, that's negative PU over N. Yung PU natin is the 3060. N is the number of piles. Hindi siya divided by the area. Para diretso force yung ating makuha, just divide it by the number of piles. The plus or minus MUY times C over inertia per area. Alright? So, yung inertia per area, since it is rotating about the y-axis, alam natin, transfer formula, IX plus AD squared. I mean, inertia, gross inertia plus AD squared. So, we can consider or we can neglect the individual moment of inertia of each pile kasi maliit yan. Negligible yan sa calculation. Kaya, yung matitira dito is summation of ND squared. Instead na area, number of piles yung ating gagamitin. Okay? Kasi, kinonsider natin to as per area. Para makuha natin is already the force. So, we have, since ito yung ating neutral axis, itong tatlo, itatransfer natin dito. Okay? Tatlong piles, itatransfer natin sa neutral axis. And 1. So, the distance is 1.2 center to center. That's 1.2 squared. Ito naman, itong tatlo, itatransfer natin dito sa neutral axis. So, another 3 times 1 point squared. And itong nasa gitna, on line 2, hindi na natin yan kailangan i-transfer kasi nasa gitna na yan. Nasa neutral axis na siya. So this is the inertia per area. Alright. So, RU1. To solve for RU1, gamitin natin itong general formula. You have PU over N. 3060 over 9 piles. Negative kasi compressive yan. Alright. So, take note, ito pinupush yan. Pinupush ng moment. So, yung gagamitin natin na sign is negative. Kasi pinupush yan for compression. So, negative, the moment is 1080. Yung C natin, that's the distance of this line 1 to the neutral axis. You have here 1.2. And the inertia per area is 8.64. So, you will have negative 365 kilonewtons. So, ito yung critical reactions on the pile. And lahat ng critical stresses is based here. Kunin na lang din natin yung ibang reactions just for the concept. RU2. So again, general formula lang. Gamitin natin yan. So negative 3060 over 9. Ito yung ating line 2. So MUY times C. Wala tayong C kasi andito yan mismo sa neutral axis. Kaya the term C is 0. Lahat ng yan is magiging 0 lang yan. Okay? Kaya neutral yung ating RU2 dyan. Makakancel lang yan. That is simply force over the number of piles. Yung nabanggit ko kanina. Still negative. Compressive. And for the RU3, alright, parating PU over N yan. Negative PU over N. Dito yung mag-matter yung sign and also yung C, distance niya. This time, itong pile, itong row 3 ng pile or column 3, hinihila yan ng moment. Yeah? Papunta dito yung moment natin. Hinihila siya. That means that should be in tension or added. That is plus. Okay? Yung distance naman ng line 3 is still 1.2. Kuha natin negative 315. Ito yung pinaka-critical. So, again, yung magagamit lang natin is yung maximum reaction ng pile para makuha natin yung critical. The maximum beam shear stress in the pile cap. Okay? Wala siyang binanggit na critical but it should be the, yung style niya, yung tanong niya dito actually must be the critical reaction. So since andito yung ating maximum reaction on pile 1, then ito yung ating critical section at i-distance from the face of the column. Okay? Critical section. Alright. Ngayon, ito, the distance from here. Kung titingnan natin sa side. I-gather lang natin yung mga reactions. Again, dito tayo pumili ng section kasi andito yung pinakamalaking reaction. Okay, tingnan natin dito. Tingnan natin in 3D. Yan. So, ito yung ating bars. Okay, klaro yan ha? From here, kumbaga ito yung masishear. We have here the reactions, RU1, tatlong RU1. Effective depth of the footing that's given, 0.4 meters or 400 millimeter. Yung total distance nito, ito, total distance, ito yan. I-add natin, 2.6 and 2.1. That is 3.2 meters. Ito yung shear force. That shear force can be solved by equilibrium. The shear force is tatlong RU1. No? The critical shear force. The shear force will be divided on this shearing area. Ito yung ating shear stress na tinutukoy dito sa problem. Una, yung shear force, critical shear force is tatlong RU1. RU1 is 365. Okay? So, neglect lang natin yung sign. Alam natin that that will cause the shear, the critical shear. So, you have 1,095 kilonewtons. And para maging shear yan, divided by area. Force over the area. The wide beam shear stress. I just denoted that one as tau, no? Sometimes, gidenote ko siya sa ibang videos as V, small v. So, basta shear. Force BU over the area. Ito yung BW times effective depth. Okay? So, we have the shear force, the area, 3.2 meters or 3,200 millimeters. Effective depth is 400 mm. So, this is the design shear. The design shear at critical section. Wala siyang term na design. Ito yung na-notice ko sa mga question niya. Basta sometimes meron siyang term na design. That could mean that is the factored. Yung hindi natin dinivide ng P. Factored shear. Pag wala siyang term na design, then nominal. I-divide natin siya ng reduction factor for shear. So, 0.855 over 0.75. That's 1.14 megapascal. Okay? That's letter B. Lalabas ito sa choices. But again, yung titingnan lang natin dito is yung term na design. Pag design yung term niya, then wala kang fee dito. Pag walang term na design, then divide it by fee. That means nominal yung pinapakuha. Okay? Punching shear stress on the most heavily loaded pile. So, hindi punching shear stress sa column yung tinatanong. Most heavily loaded pile. Obviously, yung heavily loaded pile natin is itong column 1 of the pile. Kasi RU1 yung ating reaction, which is 365. Pinakamalaki. So, it's either of these three. No? Kahit saan sa tatlo, the same reaction naman sila. So, alam natin, but for a punching shear, that happens at a D over 2, yung critical section. Base yan sa code. Ito yung ating critical section. Ito yung matatanggal, yung part na yan. So, titingnan natin siya sa 3D. So, we have here RU1, effective depth. Then, ito yung ating shear force. Shear force BU. That will be by equilibrium pa rin. For this heavily loaded pile, yung ating shear force dito is just equal to RE1. No? And that shear force is distributed on that shearing area. These are the shearing force, shearing stresses. Okay? So, kung titingnan natin yung ating section, the pile is at 350 mm, by the way, no? Binigay ito sa problem. The pile is 350 mm squared. Effective depth is 400 mm. So if this is 350 mm or 0.35 meters squared, this is D over 2. D over 2 then on the other side. That means the total distance here is 0.35 plus D over 2 plus D over 2 on the other side. 400 mm. So 0.35 plus 400 mm or 0.4. This will give us a total of 0.75 meters. The same dito, 0.75 meters. Okay? So, yung ating shearing area is the perimeter times the depth. That will be the shearing area. So, again, by equilibrium, yung BU natin is equal to RE1. Is 365 kilonewtons. And the punching shear stress is force over BOT. So, ganito siya sinulat sa code, BO. The BO is the perimeter. 4.75. Okay? Yung D natin is 400 mm. So, 750 millimeters or 0.75 meters times 400 mm. Ito yung punching. Kumbaga, design punching shear. Again, nominal yung hahanapin natin. Divide it by phi. You have 0.405 megapascal. 0.4, letter C. Ito, lalabas din yan, no? 0.3. Next, part 3. Determine the required spacing of 20 mm diameter bars for critical moment. A critical moment. Iba yung critical section for movement that is on the face of the column. Okay? Kung sa shear, at D distance for a moment, dito yan sa face of the column mismo. Alright, so dito natin kukunin yung critical section kasi ito yung pinakamalaking reaction. Itong reaction na yan yung magbibigay ng malaking moment sa ating column. I mean sa ating file cap. Pwede rin kasi dito on the other side. But as you can see, RU1, RU2, and RU3 yung mga reactions dito. Of course, mas liliit yung ating moment. Ito yung critical reaction. Critical section. So, moment arm Z. Each of this file has a reaction of RU1. Multiply natin ng moment arm Z. That's the critical moment at that section. Tingnan natin siya in 3D. So, yan. Okay, ganito yan ha. So, bale, ito yung nakat na portion. These are the bars. 400 mm. RU1 lahat. This is still 3.2 meters. A total of these dimensions. Then, dito yung ating critical moment. It is the reaction of this, reaction of the moment produced by this RU. So, tawagin ko siyang MUC, critical moment at that section. Ito yung Z. That one. So, yung Z, kailangan natin for the moment. Ilan yung Z? That is, okay, 1.2. Ito, 1.2. Then, minus kalahati ng column. Minus kalahati ng column. Kasi up to dito. Ito yung kalahati ng column. Dito natin kukunin yung section. So, 1.2 minus 0.6 over 2. Saan yung 0.6 here? Yan yung dimension ng column. Given yan dito. 600 mm squared column. Okay? Kuha natin yung ating Z. 0.9 meters. Then after that, the moment, the critical moment at that section is just equal to tatlong RU1. Okay? Tatlong RU1 times the distance Z. So yan, no? From here to here. Moment dito. So, RU1 times Z. So, i-react yan ng internal moment. 3 times 365, RU1, times Z na 0.9. We have 985.5 kN/meter. Okay, for a footing, pwede mo itong gamitin na procedure, no? Kunin mo agad yung RN. Kasi automatic, it is tension controlled. And bihira lang itong mag-doubly reinforce. No? Siguro sa special cases. Pero wala. Practically, hindi siya magiging doubly reinforced talaga. So, follow this procedure. Kunin mo yung RN. Resistance yan for moment. So, MUC 985.5 times 10 raised to 6 Newton millimeter. Reduction factor per moment is 0.9. Yung B natin is 3,200 millimeter. Yung ating depth is 400. So, we have 2.139 megapascal. Then, kukunin natin yung required steel ratio using that formula. Given to lahat, Fy, Fc prime, Rn, nakuha natin the previous solution. A direct substitution, Fc prime natin is 20.7, Fy is 413, then Rn is ito. So, 0.005539. Alright, but before we use that one, check muna natin si minimum. Minimum required. So, the minimum required is the larger of square root of Fc prime over 4 Fy or 1.4 over Fy. Larger. So, evaluate the two. Sino yung mas malaki dito? Yung mag-govern is ito, 1.4 over 413. Yeah, 0.00339. Mas malaki yung ating required row or hindi siya bumaba sa minimum required. Means, okay, gamitin to. Gagamitin natin yung nakuha natin. Calculate. Alright? So, kunin natin yung required steel area. Row BD. Row. Yung B natin, ito. 3,200, 3.2 meters or 3,200 millimeter. Yung D natin is 400 millimeter. The required area. Gusto natin makuha yung required spacing of 20 mm diameter bars. So, kunin natin yung required number of bars. Okay? The total area divided by area of 1 bar. We will get 22.57. Of course, round up tayo. Gagamitin natin 23 bars. Now, we will distribute this number of bars. From 23, distribute natin sa part na yan ng concrete. Okay, tingnan nyo ha. Tingnan natin. Titingnan natin to sa plane. I mean sa section. Yan. Okay? From here, titingnan natin yung section na yan. Yan. Alright. Of course, ito yung ating bars. Meron tayong top bars and ito yung bottom bars natin. So, dito kailangan natin wala siyang binigay na clear cover. So, based on NSCP, okay, this is the footing, no? Galing to sa NSCP. Kung babasahin natin, yung required minimum ng NSCP, this is cast against permanently in contact with the ground. Of course, yung footing natin is permanent na naka-contact sa ground. So, all members, minimum specified cover. That's clear cover, 75 mm. Gagamitin ko yan kasi wala siyang binigay. Okay? Now, yung clear cover natin dito is ito. Okay? Clear distance on the outer surface of the bond. So, that by the way 0.4. Gagawin na natin is i-equate natin yung distances. Lahat ng distance na to, equate natin dyan, 3.2. So, una, we have 2 covers. Dalawang clear covers. Plus, alright, nasa outer surface tayo. Plus the bar diameter. Bale, pupunta tayo sa gitna ng bars. Yan. Punta tayo sa gitna ng isang bar dito. And on the other side. Kalahati dito and kalahati dito. That gives us a total bar diameter. Then plus number of bars minus 1 times spacing. Bakit minus 1 yun, sir? Kasi kung mag-start ka dito, yung first counting natin is for the spacing, yan, 1. Of course, it will not be included, that number of bars counting. Kaya, minus 1 tayo. Okay? Plus number of bars, minus 1. Alright. Then, equate natin sa beam width, which is 3.2. Bali, yung magiging formula natin dito is yan. Hindi yung hindi applicable yung spacing which is AS, ano ba yung ginagamit nyo dito? Area of 1 bar over AS times 100. Or it can be termed as ito. Rho D. Basta meron kayong formula dito. You cannot use that one. That is only considered pag continuous yung ating width. Like slabs per meter. Like slabs kasi ito yung kinonsider dyan eh. Yung bars natin up to dito talaga. Basta continuous yung ating width. We have here a definite width. So we will not use that one. This is the correct way. Alright, kung i-substitute natin 3,200 minus 275, dalawang cover, minus the bar diameter used is 20, over number of bars is 23, then minus 1. Ito sana yung correct answer. 137.73. Okay, but wala siya sa choices. By the way, these are the exact choices of the examiner. Meron akong trinay dito. May error siya, no? Baga, maraming possible sources of error na dito. Ito yung una kong ginamitan ko ng MATLAB para mas mabilis. Sa tingin ko dito siya nagkamali. Alright. So, I have here the MathCAD solution. No? Ito lang yung process na ginawa natin kanina. Ito yung row, then row BD. Number of bars, 23. Then, ginamit ko yan. Okay? Now, it can be, dito nagkamali yung ating examiner. No? Maraming possible na errors dito eh. Sa tingin ko dito, yung ginamit niya, instead na 3,200, which is that one, posible ito yung ginamit niya na width, which is wrong. But there's a possibility, yan yung nagamit niya na width. Yeah? Wala nakita. Ito. Instead na ito yung ginamit niya na width, it can be ito yung ginamit niya, which is a total of 3.6. Ito is 3.2 lang yan. Which is that one. Try natin. I just used MathCAD para madaling baguhin. No? Instead na 3,200, naging 3,600. Look, may lalabas. 155, which is letter A. No? So, kung ako yung sasagot dito, 155 yung isasagot ko. Now, another na possible na mali niya dito, may nakita kasi ako online, kasi yung solution niya is ni-round up yung ating the required ratio. Balik ko lang sa original, 3,200. Ito, ni-round up nila, ni-round down. Ginawa niyang 0.005 lang. Disregard ito. Kasi kung i-round up natin yan, 006. Ginamit niya 005. Okay? So, kung ginamit niya yung 005, mali pa rin yung formula na ginamit niya. Kinonsider niya na parang continuous yung ating bars. Or, kumbaga, parang ano siya, slab. Yung ginamit niya na formula is ito. Alright, yung ginamit niya pala is, yung row is 0.05. Ito yung nakita ko sa online. Ito yung solution niya, no? Yung row niya is 0.05. So, yung spacing, yung ginamit niya dito, is area of the bar, pi over 4 times 20 squared, alright, times row D. Yung row, which is ito, then effective depth is 400. So still, almost 155. So ito yung assumption niya ng mali na examiner. You cannot use that one, no? Again, consider, magagamit lang natin yan pag continuous yung ating width. We have here a definite width, 3.2. Dapat bilangin mo talaga o dapat pagkasyahin mo yung ating number of bars na nakuha. Kasi hindi to slab or hindi to continuous footing or wall footing. Pag wall footing ito, then yung gagamitin natin is ito. Formula niyan. But anyway, based on the assumed error, the same answer lang kami, no? 155. Kung ako dito, 155 rin yung pipiliin ko. Basta tingin ko hindi dito yung error. Hindi naman magra-round off yung examiner natin to this small value of row lang, no? Kasi napaka-critical niyan. Sa tingin ko, ito talaga yung possible mali niya. Naging 3,600. Instead na 3,200, 3,600 yung nagamit niya. Laking chance, 155 yung answer. Alright? So again, data ito ng examiner natin, posible itong bumalik. So, ako dito, 155 yung pipiliin ko.